In this problem, we're given that we start at 140 degrees C with an overall mole fraction of 0.7. I'm going to raise the temperature and keep adding energy until we have 0.4 moles of liquid. So if we look at the diagram, we're starting here. We have to at least get to this temperature, which is slightly above 300 C, to start forming liquid. And so at that temperature, we'd have a mixture of the solid, A2B3, and of the solid pure B, and the liquid. And let's look at the point where all of B has disappeared. So we're just slightly above 300 now. That would correspond to just solid A2B2 and the liquid. So the liquid mole fraction of B is 0.8. The solid A2B3, its mole fraction is 0.6. Well, our overall mole fraction is 0.7, halfway in between. So the point where we're just above 300 means we have half liquid and half A2B3, just from the lever rule. So that would be 0.5 moles of liquid. The problem says we have 0.4 moles of liquid. So the first question that we've answered, it means we're at 300 degrees C. We have a mixture, XB for pure B, so that of course is 1. XB for A2B3, and that mole fraction is 0.6. And then the liquid, so mole fraction of B in the liquid phase is, from the diagram right here, this composition, 0.8. So we've answered now the composition and the phases, the temperature. We need to determine the amounts, and to do that we have to do a mass balance. So an overall mass balance would say the number of moles solid A2B3 plus the number of moles of solid B plus the number of moles of liquid equals the 1 mole that we start with. We can also then do a balance on B, saying the mole fraction of B in the A2B3 phase. This notation doesn't mean the subscript, just trying to indicate that phase, times the number of moles, the A2B3 solid, plus mole fraction of B in pure B, times the number of moles, plus the mole fraction of B in the liquid, times the number of moles, equals the number of moles of B in this mixture, which is 0.7. So let's substitute numbers in here and then solve for our unknowns. So let me pause and do that. So here's our first equation. Here's our second, where what we've done is just substitute in the mole fractions. And we can solve these two equations simultaneously just by subtracting equation 2 from equation 1. So we'd end up with 0.4 times the moles of the compound is equal to 0.6 minus 0.38, which gives us the moles of the compound as 0.55 moles. And this says the moles then of pure B is 0.05 moles. And then remember, liquid was 0.40 moles. So total we have 1 mole, and of that 1 mole, 0.7 moles are species B, 0.3 moles are the other component, species A. So here are the number of moles. We're at 300 C, slightly above 300 C.